I guess most importantly, happy Halloween. Happy hydrology test day, or quiz day, sorry. But I hear Allison does those all the time. So. I'm like, oh, sounds like a lot of marking. No, thanks. So today we're gonna go through the practice test too. So just kind of walking through it together. If you've had a chance to go through it and try it on your own, that's great. I'm not as generous this time. I only made one practice test, but it should give you a pretty good idea of what to expect. So here we go. Oh, now I can't remember who it was. I can't remember if it was Harjeet or Tejveer, but they both came to see me. But that assignment 5 Moodle quiz, it's not until Tuesday, so don't worry about it quite yet. In fact, maybe hold off a little bit because I want to change. It seems like one of the answers is programmed incorrectly, and so it's marking it wrong when it's actually right. So I stole these, obviously. I didn't make all these. And so I'll just have to check with the guy who made them and see what the deal be. So I guess hold off for a little bit. So let's see here. So there is likely an error.
I mean, I'm honored that we'll never.
So there's likely an error in the solutions for the log cooling questions. And so I will send out an announcement through Moodle. I know that's annoying, but maybe when someone gets it, because I know it doesn't get to everyone, maybe if someone gets it, maybe you could just forward it to your actual group, your Facebook group. Is it your Facebook group? I don't know. Yeah. Where you guys are all canoodling. There's no canoodling, huh? So I will send out a Moodle announcement. When fixed. That doesn't mean that you can't go through and do the other questions, right? So the way I've set it is, it just takes your highest grade. So you can attempt them and have practice for those other ones. But for the law of cooling, right, the temperature ones, I just want to go through and check the programmed answer because it looks like it's missing a log. But anyways. But I'm not fluent in Moodle programming, so, and it's weird or it's very different from any other programming that I do, so I'm lost. All right. Let's see what we can do here. So I put the total marks, of course, and then in the box, just like last time, it's got the total marks available for each question, just so you can kind of strategize which ones to focus on. But honestly, they're spread pretty evenly. So roughly 55 I reserve the right to change things if I feel things are wonky, but roughly. Yeah. Okay, so find and simplify the difference quotients if f of x is 3x squared minus x. So I think what you'll find was assignment 4 was massive, right? As long as you're able to handle these types of questions, which are kind of baby versions of what you did, then I'm happy, right? And that's what you can expect to see on the test. Bless you. So difference quotients, f of 2 plus h minus f of 2 over h. And so we want to have f of 2 plus h minus f of 2 over h. One thing to keep in mind with these difference quotients is the h in the denominator usually cancels out. And so if you're done and you still have an h down there, you probably did it wrong, right? And so maybe go back, make sure that the h in the denominator can cancel out. You can still have some in the numerator, but the one in the denominator will go away. So if we're careful and we're writing this out, right, because we want to have f of 2 plus h, so wherever I see an x in f of x, I replace it with 2 plus h. So I need 3 times 2 plus h squared minus 2 plus h. And I'm putting square brackets around, right, because that's my f of 2 plus h, and now I do f of 2, so minus, put square brackets around it. You don't have to, but I like to be consistent. So 3 times 2 squared minus 2, and then over h. All right, so now we expand, simplify, keeping in mind that the whole goal is to cancel these h's, and they will. You'll see. Careful with the 2 plus h squared, right? It's 2 plus h times 2 plus h, so you can't just bring the square inside. That's pretty common illegal math that I see. So 3 times 2 plus h times 2 plus h minus 2 plus h, oops. And I'm gonna show a lot more work because I wanna show you where everything went and is, right? You don't have to show all of this work, but it's nice. I am gonna simplify this little guy because I'm running out of room. So 2 squared is 4, 3 times 4, 12 minus 2. Take it slow. Could I have done 12 minus 2? Yeah. On my calculator. No. Okay. So I'm going to deal with the 2 plus h times 2 plus h. And so I have 3 times 2 is 4. 2 times h is plus 2h, plus h times 2 is plus 2h, plus h times h is h squared. That's all multiplied by 3 still, right? Oh yeah, sorry.
So at the top, you did 3 times 2 plus h squared minus 2 plus h.
Yeah.
So you had to put the 2 plus h in for every x, and then the 2 in for every x?
Yeah, so here, so f of 2 plus h, that's where we take f of x and I replace all the x's with 2 plus h. Okay. But then I also want to do minus f of 2. So same idea, but just putting 2 in for x. Okay. So that's why I use these square brackets to show that this is f of 2 plus h and this is f of 2. Oh. All right. So feels like a good time to expand the minus 2 plus h to become minus 2 minus h. And then that's all minus 10 over h. So now, well, I guess I should add my 2h plus 2h right before I bring the 3 in. Don't get sloppy, Emily. All right. 3 times 4 plus 4h plus h squared minus 2 minus h minus 10 over h. Now I can bring the 3 inside. So I get 12 plus 12h plus 3h squared minus 2 minus h minus 10. Oops, disappeared. Over h. So I can regroup this as 12 minus 2 minus 10. So that's all going to disappear, right? But I just want to show you where everything went. And then plus 12h. Oh, sorry, 12h minus h. Collecting like terms, plus 3h squared over h. I haven't canceled anything, so I can double check and make sure I have the same number of terms in both numerators. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, just want to make sure that I didn't miss anything. And then these are all going to cancel, and the 12h minus h is going to simplify, and so we get 11h plus 3h squared over h. I'm going to pull out a common h. Oh, there's a page break here. Now each term has an h, so in the numerator I can pull out that common h and have 11 plus 3h, and then over h, and that's what lets me cancel that h in the denominator. And so the difference quotient is 11 plus 3h. Okay. Any questions about that one? Great. So confidence. All right. B is the general version, right? And so what you can do, or actually probably should do, is once you have a solution for part B, is check your answer from part A to make sure you get the same thing, right? You will, right? Just with x equals 2, that's the only difference here. F of x plus h minus f of x over h is 3 times x plus h squared minus, oh no, I can't remember, minus x, so x plus h, minus f of x, which is just 3x squared minus x, all over h. Because I showed every little step in the earlier one, I will kind of speed this one up a little bit, right? So not too much. 3 times x plus h times x plus h minus x plus h minus 3x squared plus x, expanding that negative inside already. So like I said, a little bit faster, but Not too bad. So we get 3 times x squared plus 2xh. So expanding and simplifying already, plus h squared minus x. And you know what? I'm going to expand that bracket too. Minus x minus h minus 3x squared plus x over h. Bringing that 3 inside and also ditching all the brackets in the same go, I get 3x squared plus 6xh plus 3h squared minus x minus h minus 3x squared plus x over h. Like I said, a little bit faster, right? So the 3x squared is going to cancel with the minus 3x squared. And then the minus x is going to cancel with the plus x. So what I get is I get 6xh plus 3h squared minus h over h. So again, noticing that there's an h in every term, so I can pull out, I can factor out that common h, and I can say h times 6x plus 3h minus 1, don't forget that little guy, over h. H and h are going to cancel. So the answer is 6x plus 3h minus 1. Oh. As a side note, right, we can use this to check our answer from part B. I'll put it in a different color here. We can use this to check our answer. I think I said B, but I meant A. In part A, right, where x equals 2. So we have 6x plus 3h minus 1, which is 6 times 2 plus 3h minus 1, which is 12 plus 3h minus 1, which is 11 plus 3h, or 3h plus 11, it doesn't matter. Which is the same answer that we got in part A. Any questions about that one?
Solve for each
chapter. No, we don't solve for h, only because we don't know what it's equal to. Right, so we just know that it's equal to f of x plus h minus f of x over h. Yeah. So we just leave it as that. That's it. Okay. Okay. So difference quotients. Feeling pretty good? How about function composition? But like I said, baby versions compared to what you did on the assignment. Here's the thing. On assignments, those questions are going to be hard, right? Expand your mind. Work together, Google things, ask me questions, right? And so assignments should be hard, right? And they're not worth very much. And so you're allowed to make mistakes and get feedback, and that's what they're for. On tests, though, I'm a reasonable person. This is more what you can expect to see. Okay? All right. They are significantly smaller. All right. So we've got function composition. And so given the pair of functions, find and simplify expressions for the following functions and state the domain of each using interval notation. I'm pretty sure this is the only time that I make you do the domain. Oh, maybe for the inverse too, but that'll be easy. All right. So our first composition is G composed with f of x. And so let's start with G composed with f of x. I actually prefer to write it as G of f of x because for me, I don't know, it just follows the same format that we've been using, right? So I just always just rewrite it that way and remind myself that G composed with f is G of f. Right? And to be quite frank, I read G composed with f as just G of f, but that's just in my head. Try not to say it out loud, but it's also true. All right, so what I do is I write out G, and then wherever I see an x, I'm gonna put in f of x for now. And so G is 1 over t plus 3. So wherever I see a t, I'm gonna put in f of x. And so f of x plus 3. Now where I see f of x, I'm gonna replace it with 3x minus 1. So I get 1 over, and then in brackets, right, 3x minus 1 plus 3. You'll wanna make sure that when you're putting a whole function in, you'll wanna wrap it up in brackets because you never know what's gonna happen with maybe like a minus sign out front, right? In this case, it doesn't change anything, but you wanna have it wrapped up in brackets. So this becomes 1 over 3x minus 1 plus 3, which is 1 over 3x plus 2. Okay. So now for this dang domain. Don't worry, it's not that bad. The domain, so that we have to check, right? F doesn't actually have any restrictions because it's just a polynomial, right? And so it's just going to be a straight line, mx plus b.
Minus 0.
Wait, minus 0? Like, Nice. So anyways, so for the domain of f, we've got no restrictions. So I'm just gonna say from negative infinity to positive infinity. And then in general for G, we said, okay, well, t plus 3 can't be 0. And so t can't be negative 0. No, just kidding. -3. But dig in the enthusiasm. We also need to check, right, our composed function. And so the domain of G, and I suspect that I tripped you up when we talked about it. But then most of you guys handled it just fine on the assignment, so I don't know. But so we don't have to worry about the domain of G because T is actually being replaced with f of x. So the domain for us in this composed function is that f of x can't be -3, right? So, but we have g of f of x, right? So f of x can't be -3. So it takes it into account, but that t can't equal -3 doesn't come into play in this function. So f of x can't be -3, which means that 3x minus 1 can't be -3. So 3x can't be -3 plus 1. Which means I'll just skip straight to it. Which means x can't be -2/3. If you check your composed function, right, 3x plus 2 can't be 0, but that's taken care of because we already said, well, x can't be -2/3, which is what would make that 0. So if you went with the 3x plus 2 can't equal 0, or if you checked that g of f of x where f of x can't be -3, it doesn't matter which approach you took for these ones. X can't be -2/3. And so the composed domain there's no restrictions on f, but there is restrictions on g of f of x. And so the composed domain is from -∞ with up to -2/3. And then picking right back up at -2/3, right? Just that little hole up to infinity. Way more reasonable than what you had to do on the assignment. Mm-hmm. How about part B? So you can't divide by 0. No, because that's taken care of in, because what we're saying is, so the composition, right, is 1/3x plus 2. So we're saying 3x plus 2 can't be 0. So you could say, okay, well then 3x can't be -2, so x can't be -2/3. And that's where we're at. Right? So it just depends on what's in the denominator. Cool beans. Let's do another one. Just for fun. No. No. Because we want to. F composed with g of t is, I can rewrite it as f of g of t. So I'm going to start with f, which is 3x minus 1, but wherever I see an x, I'm going to write g of t. So 3g of t minus 1. And then wherever I see g of t, which is only once here, I'm going to replace it with g of t. So I get 3 times, and g of t is a fraction, right? 1 over t plus 3. And then minus 1. Okay. So what do we have to do? We have to get a common denominator for that minus 1, right? But we can expand this and say, okay, well, that's the same as 3 over t plus 3 minus 1 times t plus 3 over t plus 3. Getting that common denominator by multiplying by 1. T plus 3 over t plus 3. Now that I have a common denominator, right, I can merge the tops, right? The common denominator becomes the denominator. And so we've got 3 minus t plus 3 over t plus 3. Which becomes 3 minus t minus 3. So those 3's are going to cancel over t plus 3. So we get negative t over t plus 3. There's no restrictions on f, right? And so there's no restrictions on g of t, right? But there are restrictions on t in g of t, right? T can't be negative 3. And so maybe I'll try it in words this time. There are no restrictions on f of x oh, sorry, on f, sorry. So there are no restrictions on g of t in f of g of t. But there are restrictions. Oops, restrictions, can't spell. On t in g of t, right? Remember, t can't equal negative 3. Which checks out, right? Because in our composed function here, negative t over t plus 3, if we had t equal to negative 3, we'd be divided by 0. And so that's why it's not in the domain, right? And so we've got this hole at negative 3. And so the composed domain is from negative infinity to negative 3, and then picking right up at negative 3 up to infinity. Remember, for your domains, right? Things you keep an eye out for is dividing by 0, square root of a negative number, right? Or now the log of anything less than or equal to 0 can't have. Any questions before we do C? F composed with f of x. Should I try to squeeze it? I can I think I can. I can squeeze it in on this one page. If I cheat a little bit. Because it's just itty bitty. Remember, f of x is just that 3x minus 1, right? And so f of x is 3 times f of x minus 1, which is 3 times 3x minus 1, and then minus 1. 3 times 3 is 9x minus 3 minus 1. So we get 9x minus 4. Checking these domains, right? There's no restrictions on f. And so there's no restrictions on what f of x can be inside f of x or inside f. And there's no restrictions on x in f. So we have no restrictions. So the domain negative infinity to infinity. Just had a panicky moment. Okay, good. Now I'm always worried if I'm on mute, but I forgot to check it before I started. Today would be a bad day to be on mute. All right. Any questions about those function compositions? All right. Let's do question 3 then. So if we have f of x is 4x plus 2 over 3x minus 6, state the domain of f of x, right? Small potatoes. The domain, right, of f of x. Well, we know 3x minus 6 can't equal 0, but I don't see any other restrictions, right? There's no square roots, no logs. And so we just have to make sure that we're not dividing by 0. And so 3x minus 6 can't be 0. And so 3x can't be 6. So 6 cannot be 2. If you left it like that, because I didn't specify, that's probably just me being sloppy. But if I say you have to use interval notation, then yeah, you have to use it. But if I just said state the domain, you could just leave it as x not equal to 2. Because everything else goes, right? But if we want to be proper, we'll use interval notation up, so from negative infinity up to 2, and then picking right back up at 2, going to infinity. But like I said, I didn't say so. Next, we're going to show that f is 1-to-1 algebraically, right? So not graphically, because you don't have Desmos in the test, right? But we can show it algebraically. And what does that mean? It means that showing that f of a equals f of b, in the end, we end up at a equals b. Well, divided house, Trump impeachment. I don't know, just reading the headlines. Yeah, everyone's like, oh, save for later. Okay, so f of x, let's see if I have it here, 4x plus 2 over 3x minus 6. So f of a is 4a plus 2 over 3a minus 6. And then f of b is 4b plus 2 over 3b minus 6. Got to keep these straight in your head. So now we actually have to shift things around and solve. And as we're simplifying, what you'll find is that it will reduce to a equals b. Yeah? If it doesn't, you did it wrong. And you should probably start over. Because it will be 1-to-1. All right, so bringing 3b minus 6 over to the left-hand side and 3a minus 6 over to the right-hand side, right? Cross-multiplying here. So we've got 4a plus 2, and put all these in brackets now, right? Because we're multiplying 3b minus 6. So times 3b minus 6 is 4b plus 2 times 3a minus 6. All right, everything's on the same plane now, so that's good. Now it's just a matter of expand and simplify. So we'll expand this left-hand side, and so 4a times 3b is 12ab. And you might want to give yourself more room, probably even more room than I gave myself, but that's okay. So 12ab, 4a times negative 6 is negative 24a, plus 2 times 3b, plus 6b, plus 2 times negative 6, so minus 12. Similar actions on the other side. We get 12ab, 4b times negative 6, negative 24b, plus 2 times 3a is plus 6a minus 12. Okay. You can see that this 12ab and this 12ab and this 12 and that 12, they're going to cancel out. So what I'm going to do is I'm going to shift the 12ab and the 12 over to one side so that they can cancel out. But then also move, so then I've got 24a or minus 24a and 6b on this side, and minus 24b and 6a on this side. So I'm going to move the a's to one side and the b's to the other side. So what that's going to look like is I've got 12ab. I'll keep the a's on the left-hand side, minus 24a, but then move the 6b over to the right-hand side. And then I'll keep my minus 12, but then also do minus 12ab. Oh, sorry, yeah. And then plus 12. Equals minus 24b. Oh, I forgot to move my 6a over, sorry. Should have done it in 2 steps, but it's okay. Just being lazy. Minus 24b minus 6b. Probably one of those times that you want to count the number of terms just to make sure that you've got them all. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Phew. So now 12ab is going to cancel with 12ab, and minus 12 is going to cancel with 12. Negative 24a minus 6a puts us at negative 30a. And then negative 24b minus 6b puts us at negative 30b. And so a is negative 30b over negative 30, which of course is going to cancel. And so a equals b. Woohoo! Therefore, f of x is 1-to-1 and invertible. Because it's only invertible if it's 1-to-1, but if we're able to say it's 1-to-1, then we know it's invertible. Yeah.
Why did you leave the 24 minus 6, or the 24 b minus 6b on that side?
If you wanted to, you could have shifted everything over and put it equal to 0, right? Because then there'd be 0 left. But what I decided to do was I would put all my b's on this side and all my a's on this side so that I end up with a equals b. But you could have shifted everything over to be safe, canceled, simplified, and then moved your 30b over to the right-hand side. Yeah, so there's a couple of different routes that you could have gone to simplify this.
I can't read the last one.
Oh, invertible. Yeah. Well, let's see here. Still kind of bad. I have to use a trick where you zoom in really big, write it, and then when you zoom out, it looks perfect. Looks really nice. Oh, I don't know what's going on here. Okay, so now we know that f of x is invertible. What's next, I wonder? Oh, what a surprise. Find the inverse. I'm actually going to put it on a new page. Find the inverse of f of x, which is f inverse of x. All right. Remember that f of x was 4x plus 2 over 3x minus 6? I'm going to say that f of x is y, right? They're interchangeable. If you want to think of f of x as y, that's fine. And then to find the inverse, remember the rule is, okay, you're going to replace all your x's with y's and all your y's with x's, and then solve for y. So what we have is we're going to find x is 4y plus 2 over 3y minus 6. Solve for y. Solving for y, right, we have to move the 3y minus 6 from the denominator up to the top, multiply it by x. It's going to get a little messy for a bit here. X times 3y minus 6 is 4y plus 2. Can expand this so we get 3xy minus 6x is 4y plus 2. Remember, we're solving for y, so I want to bring that 4y over to the left-hand side, but also I don't need that 6x over on the left, so I'm going to move it to the right. So I get 3xy minus 4y is 2 plus 6x. Right. Doing some switcheroos to be able to solve for y. Now I've got a y in both the terms on the left-hand side, so I can factor that out and I can say that y times 3x minus 4 is 2 plus 6x. Solving for y, then we get 2 plus 6x divided by 3x minus 4. I don't like the asymmetry of 2 plus 6x and then over 3x. This. as y equals 6x plus 2, nothing changed there, and then 3x minus 4. But that's just personal preference. The first one would have been fine. Therefore, the inverse of f of x is 6x plus 2 over 3x minus 4. Paper is nice to have.
That's it.
Right, so we've got our inverse function. Oh. Good.
Is there a reason that you just put that beside the 3y minus 6?
Oh, it's because we have to, so to solve for the inverse, the trick is to replace all your y's with x and all your x's with y's.
Oh, so you just
And then solve for y. Yeah, so then in an effort to rearrange this to solve for y, right, I'm going to multiply this over here by the x.
Okay.
Cool. Okay. So we're going to state the domain of the inverse of f. And so the domain of f inverse of x says that we can't divide by 0 again, so 3x minus 4 cannot be 0. But I don't see any square roots, I don't see any logs, and so that's our only restriction. And so we can solve for x and say that 3x cannot be 4, and so x cannot be 4 over 3. Remember, as a rule for the inverse of a function, the domain of the inverse is the range of the original, right? And the domain of the original is the range of the inverse, right? So they kind of, I don't know, go hand in hand. I don't know how to show it, right? And so, so therefore we know the domain of f of x, f of x and I'm going to cheat and just say that x cannot equal 2. I know we used integral notation, but I didn't specify. And you could get fancy and say that x is in the set of real numbers as long as x is not equal to 2, but we can just say x equals or cannot equal 2. That's fine for this one. Of course, if I say use interval notation, then you should, but here I didn't. So the range of f of x is the domain of the inverse, right? And so that means that f of x cannot equal 4 over 3, right? Or y cannot equal 4 over 3, if you want to write that. Again, f of x and y are just interchangeable. And the domain of the inverse of f of x is that x cannot be 4 over 3 And knowing the domain of f of x, I also know the range of the inverse of f of x is that, f of x, sorry, f inverse of x cannot be 2, right? Or y can't be 2, if you prefer, just dealing with x's and y's. Okay. Any questions about that one? I didn't specify, so it's only if I say use interval notation that you have to. Yeah. And also I'm dealing with a page break here, so I'm getting lazy. All right. So part E, use function composition to prove that the inverse you found is indeed the inverse of f of x. You must show both ways, right? So what that means is, well, by the properties of the inverse, the f composed with the inverse of f has to equal x, and the inverse composed with f has to equal x. Right? And so we already know what our answer has to be. So if that's not the case, then we've done something wrong, right? So a lot of these questions are just letting you check your answers to make sure that you're on the right track. And so the first way is that f composed with the inverse of f of x, does it equal x? So f composed with the inverse of x is f of, g, no, f inverse of x. F was 4x plus 2 over 3x minus 6, so we've got 4 f inverse of x plus 2 over 3 f inverse of x minus 6. F inverse we found was 6x plus 2 over 3x minus 4. So we've got 4 times 6x plus 2 over 3x minus 4 plus 2, and then that's over 3 times 6x plus 2 over 3x minus 4 minus 6. This will reduce to just x. We just have to stick with it. Common denominators. We've got a fraction over a fraction, so we're going to flip and multiply. Flip and multiply. Four times 6x, so just kind of bite-sized pieces here. 12x plus 8 over 3x minus 4. And then plus 2, I'm going to start putting this over a common denominator, multiplying by 3x minus 4 over 3x minus 4. Do the same thing with the denominator. 3 times 6 is 18x plus 6 over, 3 times, oh, I'm on the wrong one. Sorry, I was like, what, 12? No, that's not. Anyways, what are you guys reacting to?
4 times 6 being 24, not 12.
Usually, yeah. Thank you. I don't even have the excuse because it's the same on the next one too. I was looking at the wrong space. That's why I was like 18. Wait, that's not what I had. Just want to be careful. Good. Thank you. That was just to test you guys. So 18x plus 6 over 3x minus 4 minus 6 times 3x minus 4 over 3x minus 4, right? Getting it over that common denominator. I have 24x plus 8. Hopefully I didn't screw that up. No, looks good. Plus 2 times 3 is 6x. 2 times 4 minus 8 all over 3x minus 4. And then that's all over. It's all over 18x plus 6 minus 18x plus 24 over 3x minus 4. Fraction over a fraction, right? You flip the denominator and you multiply fractions. But I also have some simplification to do, right, in both the numerators. So I'm going to do that as well as the flip and multiply in one go. Wish me luck. 24x plus 6x makes 30x. 8 minus 8 is 0, so 30x over 3x minus 4 times, and then 3x minus 4 over 18x minus 18x, just goes to 0. And then 6 plus 24 is 30. Because we're multiplying, right? 3x minus 4 cancels with that 3x minus 4. And this 30 cancels with this 30. And it equals x. And that's a good thing.
Where'd you get the bottom right 30? Sorry.
Because it's from 18x minus 18x is 0, right? And then 6 plus 24 is 30. But when we flip this, right, the 30 becomes a denominator.
Right, so the 3x minus 4
Is, yeah, so when you're dividing fractions, the bottom one flips and multiplies. So the top one holds steady.
So the same on the top. It was like 24x plus 8 plus 6x minus 8 over 3x minus 4 times 3x minus 4 over.
That's right. Yeah. I just simplified as well. Great. Now we do the other way. But like I said, what's nice about these is you know you have to get to x, right? And so you know if you've done it right. It will be kind of messy, but it will reduce. So now we have to check that, I'll use this page break here. The inverse composed with f of x, does it equal x? And so the inverse composed with f of x is f inverse of f of x. The inverse was 6x plus 2, so we've got 6 f of x plus 2 over 3 f of x minus 4. And f of x is 4x plus 2 over 3x minus 6. So 6 times 4x plus 2 over 3x minus 6. And then plus 2, don't forget that little guy, times 3 times 4x plus 2 over 3x minus 6 minus 6. Crap. Sorry. Minus 4. Yeah. Yeah. Good. All right. Same drill. Common denominators, dealing with fractions, simplifying. We can do it. All right. 6 times 4 we already established was what? 12, 18? Now, I'll go with 24 again. It's nice, but not necessary. 24x plus 12 over 3x minus 6, and then plus 2 times 3x minus 6 over 3x minus 6. Three times 4, I've got 12x. Now I'm all doubting myself. Plus 6 over 3x minus 6. Minus 4 times 3x minus 6 over 3x minus 6. Now that we've got the common denominator, we can combine all the numerators. So 24x plus 12 plus 6x minus 12 over 3x minus 6. And then that's all over 12x plus 6 minus 12x. Oops. Minus 12x plus 24 over 3x minus 6. Okay. Twelve and 12 are going to cancel, and 12x and 12x are going to cancel. So I've got 24 plus 6x, 30x over 3x minus 6, and then flip and multiply, so I've got times 3x minus 6 over 6 plus 24, which is 30. 3x minus 6 is going to cancel with 3x minus 6, and the 30 cancels with the 30, and I am left with, drum roll please, thank you, x. Therefore, f inverse of x equal to 6x plus 2 over 3x minus 4 is the inverse of f of x equals 4x plus 2 over 3x minus 6. Any questions about that one? Yeah. So solve in each case for the required quantity. Kind of a lot easier than what we were just doing. Right, nice break. So we've got pH, which of course is just one thing. So context kind of tells you if it's one thing, even though P times H could totally be something like that. But for us, of course, pH is just one thing. pH is 5.4 plus the log of 300 over x. We're going to solve for x. So we've got pH is 5.4 plus the log of 300x, or 300 over x. Just rewriting the function or the equation. So to solve for x, x is inside the log, right? And so what I want to do is I want to isolate the log. So I have to do pH minus 5.4 is the log. This is log base 10, right? If it doesn't say a base, it's the common log, which is log base 10, which is 300 over x. I'll put the base on there, log base 10. You could break this up, but I'm not going to, right? It would be the log of 300 minus the log of x, but that just feels like more work, actually. So what I'm going to do is I'm going to raise both sides to a base of 10, and then the sides are going to be the powers, right? And that's how we undo the logs. And so log base 10, we have to use a base of 10. And so we get 10 to the power of pH plus 5.4 is 10 to the log base 10 of 300 over x.
But you make it fine.
Oh, I didn't. See? Thank you. And good eye.
How do you know that pH is in the equation? Like, why wouldn't you bring over the 5.4? Why is there
Well, because pH is a place, it's a variable, right? So it's a placeholder for a pH level. And so it also has to get raised to the 10. I'm solving for x, but pH has to be involved in that because it's in the equation. So now on the left-hand side, we're kind of done, right? We've got 10 to the power of the pH minus 5.4. And then the log, 10 to the power of log base 10 goes away. So the 300 over x just drops down. And that's why we use the base of 10 to cancel the logs. So now to solve for x, I'm going to move that x over to the left-hand side, but then divide both sides by 10 to the power of pH minus 5.4. And so I get 10 to the power of pH minus 5.4 times x is 300. Solving for x, I get 300 over 10 to the power of pH minus 5.4. So just manipulating equations, being able to solve for different things. Once you've solved for x, then you're done. Same deal here. We've got mu as mu sub m times s over k sub s plus s, and we're going to solve for k sub s. So I like to write out my equation that I'm working with. But that's okay. That's what X is. So we will have lots of variables in there. And so we're just moving around different variables and manipulating just the variables. So it's not going to solve to a number or anything. So same thing here, right? We've only got variables. And so we're going to shift them around. So we've got mu is mu sub m times s over k sub s plus s. And we're going to solve for k sub s, which means that we slowly want to just get k sub s on its own. So we kind of shift things around, right? Isolate the fraction with k sub s, right? Otherwise we can't do anything. Well, we can actually, but because we're multiplying. So how do we want to do this? There's a couple of ways, actually. You know what? Yeah, let's do it. Mu is mu sub m times s over ks plus s. Like I said, there's lots of ways that you can do it. To get k sub s on its own, I have to multiply both sides by k sub s plus s. And so I get mu times k sub s plus s is mu sub m times s. Getting k sub s on its own, I'm going to divide both sides by mu, so I get k sub s plus s is mu sub m s over mu. Subtract s from both sides, and we're done. K sub s is mu sub m times s over mu minus s.
Do you know what you're solving for?
Oh, so, and then I say solve for f, k sub s.
Oh, yeah, don't see it. There it is.
It's kind of baked in there. So let's do the last one of those. So we've got Q equals C A sub 2 times 2G times H1 minus H2, and then that's all under the square root to the power of 1/2 for H1. So we want to solve for H1. So writing it out again, just so I can see what I'm working with here, is Q is CA2 times 2G times H1 minus H2 to the power of 1/2. Solving for H1, I'm slowly gonna pick away at this. So I divide both sides by CA2, and so I get Q over CA sub 2 is 2G times H1 minus H2. And all of that is technically under a square root, right? But we're denoting it by a power of 1/2. So in order to get at the H1, we have to take the square of both sides. And so we're at Q over CA2 squared is 2G times H1 minus H2. Dividing both sides by 2G, I get Q over CA2 squared divided by 2G is H1 minus H2. Solving for H1, I have to add H2 to both sides, but also I like to have what I'm solving for on the left, personal preference. And so I'm going to revolving door this and say that H1 has to be Q over CA2 squared over 2G plus H2. And that's it. Nice and breezy. Any questions about those ones?
Values of squared only on the Q over CA.
Oh, because I ditched it. Because the to the power of 1/2, right? When I take that to the power of 2, it becomes to the power of 2 over 2, which is just 1. Because remember, the power of 1/2 is just the square root, right? So I'm just undoing the square root. All right. Question 5. Oops. The pH of a solution is a measure of its acidity or alkalinity. Surprise. Specifically, pH is the negative log of H plus, where H plus is the hydrogen ion. How are you supposed to say that? H positive, H plus? Oh, it's like something stuck, I guess. I don't know. H plus is the hydrogen ion concentration in moles per liter. A solution with pH less than 7 is an acid. One with pH greater than 7 is a base, alkaline, and a pH of 7 is regarded as neutral. This is probably not news to you, but here we go. The hydrogen ion concentration of pure water is 10 to the negative 7. Find its pH. What's nice about this one is, well, you know what the pH should be, right? And so let's do it. So you've got pH is the negative log of H plus. So pH is the negative log of 10 to the negative 7 in this case. Bless you. We can just do this on our calculator, right? It's log base 10 because it doesn't specify, right? And so you've got the negative log base 10 of 10 to the power of negative 7 is 7. If you want to, you can show, right? So you take the negative log base 10 of 10 to the negative 7 is negative 7, which is 7. Right? But that's by the properties of logs, right? If you take, so that's on one of these handouts if you don't have it. So that's kind of nice. Let's do part B. Find the pH of a solution with H plus of 6.3 times 10 to the negative 13. Same idea though, right? pH is the negative log of 6.3 times 10 to the negative 13. But just use your calculator. Negative log base 10 of 6.3 times 10 to the power of negative 13. You're going to get 12.20065.945. fish. I'm just gonna leave it as that. On the test, what I'll just tell you to 2 decimal places or something like that. So then just follow instructions, but for now I'll just leave it like that. Okay. So make sure that you're getting those same answers on your calculator, right? Don't want to have mistakes on the test for something easy like that. In order to successfully breed Ipazuti fish, turns out they're fake, but fun to say. Ipazuti fish, the pH of a freshwater tank must be at least 7.8, but can be no more than 8.5. Okay. Determine the corresponding range of hydrogen ion concentration. Okay. So what we're saying is that, okay, the pH has to be between 7.8 and 8.5. We're trying to solve for H+, so we're going to replace pH with the negative log of H+. So we got 7.8 has to be less than the negative log of H+, which has to be less than 8.5. They're like a squealing or something going, oh, crazy. So now, remember we solved one of these last day where, okay, if we have to remove the negative, right, divide or multiply by -1. If we're dividing by -1, the sign switches, right? So we have to be really careful. And so we've got -7.8 is greater than the log of H+, which is greater than -8.5, right? So I want you to be really careful about how those change. So now what I'm gonna do is I'm just gonna flip this on the, I don't know, revolve it again, I guess. And so because I like to have my smaller number on the left and my bigger number on the right, because then I can just use less than less than. And so what I get is -8.5 is less than the log of H+, which is less than -7.8. Now this is log base 10, and so to get rid of that log, I have to raise everything to the power of 10, or 10 is the base, sorry. I don't know how else to say it. 10 to the -8.5 is less than 10 to the log of H+, oops, H1. Which is less than 10 to the -7.8. So now we have H+ has to be between, and if you leave it as 10 to the -8.5, unless I say use scientific notation, but if you tried to do 10 to the power of -8.5, your calculator actually just gives it to you in scientific notation. So, and it just looks better. So 3.6 or 3.16 times 10 to the -9. It's just easier to wrap our heads around scientific notation than 10 to the -7.8, for example. I get 1.58 times 10 to the -8. Any questions about that one? Oh, pretty good. I realized that I forgot to put a Newton's law of cooling or warming on the practice test. That's okay, I'll save it for the final, I guess. I don't know what happened. So, that's all right. There won't be one on this test, I guess. But they all behave the same way, so it doesn't matter. Suppose a bacterial population in water doubles every hour. So this is where you need that breakdown of the couple of models that we went through, right? And so we've got the doubling time, and so you're going to use that first equation, the doubling time. So side note, same deal, right? You've got one piece of paper as your formula sheet. You can put whatever you want on there, whatever you want. There's no honor in having a small formula sheet. Don't worry, I'm not going to judge you for what you put on there. Although I'm always curious to know what you put on there, but just make good formula sheets, okay? You'll be all set. So we've got the doubling time. And so if the population starts with 6 organisms, how many will there be after 2 days? So I guess I did, oh well, maybe. So this is a doubling time. The doubling time is doubles every hour, so 1 hour, which in our formula, that's going to be A, right? The doubling time. Our initial population, right, in n of t equals n sub 0 or n naught times 2 to the power of t over a. Right, in part A, oops. Part A, we're given that n sub 0 is 6. And we want to know how many will there be after 2 days. And so T is going to be 2 days. But here's the thing. Doubling time is in hours. So we need to have T in hours, right? They always have to match up. And if you're given the doubling time, you want to match whatever the units are for the doubling time. So 2 days is 48 hours. So then if we write out n of t is n sub, just writing the general formula, n sub 0 times 2 to the t over a, n at 48 is 6 times 2 times 48 over 1. So we get 2 to the power of 48 over 1, but it's just 48. And then times 6, I get 1.689 times 10 to the 15. And again, I'll specify how many decimal places you'll need to get. Part B, again, if the population starts with 6 organisms, how much time is there until it reaches a level of 500,000 organisms? So part B, now we've got n of t is 6 times 2 to the power of t over 1. And we're going to force that to be 500,000. And solving for t. So if we do 500,000 divided by 6, 1, 2, 3, 1, 2, 3 divided by 6. I get 2 to the power of t is 8,333.3333, whatever. 33333. Calling it. I'll keep my decimals in here, of course. So I'm going to use log base 2, right? Because then I just get to t, and it doesn't matter because your calculator does all the bases, right? And so we've got log base 2 of 2 to the t is equal to log base 2 of 833.3333. So t is going to be log base 2 of that previous answer. So I just use the answer button equals, and I get 16.34660607 hours. And again, what you have to round to, I'll tell you in the test. Ready for 7? Well, buckle up. A radioactive isotope has a half-life of 16 months. This has a typo in it that I forgot about, but that's just for you. Where is the typo? I mean, you could, but it wouldn't be worth 3 marks. It'd be worth 1 mark. So I guess maybe the easiest typo is this. Change it to 1 mark. Why am I saying that? So for radioactive decay, right, you've got the function. The function is A of t is A naught times e to the kt. But without any more information, that's all you can do for part A. So it actually should have said, so, or find a function which gives the amount of the isotope, the amount remaining from 57 grams of the isotope in grams T months later. That's a bit more work. You'd have to do it in part B, but then part B should be worth more marks anyways. As it stands, that would be the answer. But for us, part A, we're going to say, okay, well, the half-life is 16 months. And so if we let A sub 0 be 57 grams, so we're going to do what I meant for the question to be. I just got sloppy. So the half-life is 16 months and the initial amount is 57 grams.
I can make
Oh, it's
F.
K over T.
K over
K T.
Oh yeah. It's my K.
K.
Now you know.
Yeah.
Yeah. Okay. So now if we know the half-life and we know the initial amount, right, then we know that, okay, well, at A of 16 months, right, so T is in months. The amount remaining is half of 57, 57 over 2. So it has to be 28.5. 28.5. We use this to solve for k, right? So we've got a of 16 is 28.5, which is also 57 times e to the k, and t is 16. Solving for k, right, we can divide both sides by 57, right? Isolate the exponential function, so we get 28.5 divided by 57 is 0.5, of course. Not sure why I did that on my calculator. Is e to the 16k. If we take the natural log of this, the e is going to go away, so we get the log of 0.5 is 16k times the log of e, just for completeness. If you didn't want to write the log of e, that's fine, because it's just 1. Solving for k, we get k as the log of 0.5 over 16. We usually just use a decimal approximation for k, and so k is roughly equal to the natural log of 0.5 divided by 16, negative 0.0433. 28 divided by 57.
No. Oh, yeah, I'm with you.
Great. So that's what I meant for the question in part A to be, basically solving for k, but the question said, give me a function. So then a of t is 57 times e to the negative 0.0433 t. Because the question actually asked for the function, not just k. Part B, how long will it take 57 grams to decay to 12 grams? Right, so solving for time, we want to find, okay, well, a of t is, we're forcing it to be 12, but it's also equal to 57 times e to the negative 0.0433 t. So again, 12 over 57 is not a nice number, so I'm just going to leave it as 12 over 57 is e to the negative 0.0433 t. Solving for t, we take the natural log of both sides, so the log of 12 over 57 is negative 0.0433 t. Picking up the pace because I am feeling the crunch. T is the log of 12 over 57 divided by negative 0.0433. So the log of that guy divided by negative 0.0433. I get 335. T is 35.984,86416. And time is in months. Part C, what's the average rate of change of the amount over the time interval 2 years to 3 years? Rate of change? What the? We know what that is though, right? So we want to know the average rate of change is, well, in general, over AB, right? In general, it's going to be f of b minus f of a over b minus a. So in this case, we're going to solve for a of 3 minus a of 2 over 3 minus 2. And that's going to give us the rate of change over that time frame, right? 2 to 3 years. A of 3, you're just going to use your calculator, right? A of 3 is 57 e to the negative 0.0433 times 3 minus 57 times e to the negative 0.0433 times 2 over 1. So I'm gonna not write it as a fraction anymore, yeah. That is a good catch. To save some time here, 2 months, 3 months, thank you. This question is riddled with typos. That's how you know it's going to be the one that's most worked over for the test. Anyways, from 3 to 2, I get negative 2.215053909. Not showing my work from the calculator. There is one more question, right? But what I'm gonna do is I'll just, because we're out of time, I'll write the solutions out and then I'll post the notes. So make sure you have a look at them and let me know if you have any questions about them. And make sure you pick up any handouts, but also very importantly, you have to grab a lot more candy than you did. It's a long day ahead. Hydrology quiz.
Not sure how to do them log-based.
So you use this log.
Oh, I see.
Oh, look. That's so weird. So mine, if you do, oops, if I do this one, hit that one, it gives me this. But yours, so maybe it's in the menu. Because see how it gives me a little drop down?
Yeah.
But we have the same calculator. Did you change any settings, maybe? Let me just end this recording.